Hello class, I just wanted to make a video to help you with the calculations for the homework that's due this Saturday night. So let's get started with some similar questions. First, calculating opportunity cost. So here we have a graph that shows us the comparison of producing tanks versus trucks. So with opportunity cost, there's two activities you can choose between, and by doing more of one, you must give up less of another because you're devoting resources to it, being inputs like steel in the case of trucks and tanks, rubber, that sort of thing, as well as workers and laborers and other machinery to produce the products. So we see here that if we decide to produce 0 trucks, we can have 5 tanks. But if we want to add a truck to our production, that means we no longer have 5 trucks, but 4.5. So the opportunity cost, meaning the cost of adding that first truck, is giving up 1/2 of a tank. So opportunity cost is measured in the amount of the other item that we're giving up. So I left this first one blank, and that was intentional. There's nothing before 0, so we can't see that change from that point. Okay. Then when we look from going from one truck to 2 trucks, it means we're going from 4.5 tanks to 3.8 tanks. So now we are giving up 7/10 of a tank. So it's still measured in tanks, but the amount is different when we add a second truck instead of just going to our first one. Then when we go from 2 trucks to 3 trucks, our tank production goes from 3.8 to 3.0. So by adding that third truck, the total number of tanks we can produce goes down by 1/8. So our cost, or our opportunity cost, is 8/10 of a tank. When we go to 4 trucks, that means before we had 3 tanks, now we only have 2. So now we are giving up 1 whole tank. Then when you decide to build 5 trucks from just 4, you go from 2 tanks to no tanks. So that last truck costs us 2 tanks in opportunity cost sense. So if you notice that as we increase our truck production, even though it's only going up by 1 truck each time, our opportunity cost is rising. Right? So that's the section on increasing opportunity cost. The idea being that when we decide to make 1 truck instead of no trucks, we pull our best truck workers over. And then when we make the second, we pull our next best truck workers, as well as other machinery and materials. And so we don't have to give up very much tanks, because the people who are good at trucks relative to tanks aren't as costly to lose. But as we increase trucks more and more, we're having to pull our better and better tank workers away from making tanks, right? We leave them to the end. That's why they can make so many more tanks than the first few people we pull away. Okay? So that is an example of how you would calculate opportunity cost. The next calculation question is on page 28, question 9, and it asks you to look at this graph and determine which nation has a high faith in free market and which one has a low faith in free market. And so to determine the one that has a high faith in the free market, well, let's look at the question. It says that free enterprise system and a free market economy is the best system on which to base the free future of the world. So the people who agree with that statement would have a high faith in the market. So we would be looking here for lots who agree in the nation. So a big blue bar, in other words. So which of these nations has the biggest blue bar? Whereas those that have the low faith in free market would have very few who agree. So this would be a small blue bar. Okay. So you're looking for this nation with the smallest blue bar here. Okay. So using that, you should be able to apply it to the picture and determine which nations have the highest and the lowest faith in the free market system. And then the next question wants you to calculate what fraction of GDP is produced by in your homework it's 3 of the largest nations and 3 of the smallest. So I'm just going to do 2, so you'll have to do a little more to get the answer in the homework. Okay, so the 2 largest nations here in our graph are China with $10.1 trillion of GDP, and the United States, which has $14.6 trillion of GDP. So we add those together to get the total for both nations, and that comes to 24.7 trillion. But we want to know what it is as a percentage of the total amount produced by these nations. So if we want the fraction of the whole, that means we're going to have to take the amount for our 2 nations and divide it by the 75. Now both of these are in trillion, which is nice, because that means it cancels out and we don't have to deal with all those zeros. Okay? So 24.7 trillion divided by 75 trillion comes to 0.3293, or, since this asks for a percent, 32.93%. Now most of the places in Canvas I've included instructions about how to round, so be sure to follow those rules. I will check behind Canvas and make sure that there's not something that you were just slightly off on, or that is a rounding error because you did a different number of decimals. So I will be checking on that. If there's something that seems suspicious after you submit it, please let me know, and I will take a look. Okay. So then with that question, there's another one, or the last part of it, asks you how much larger the U.S. economy is than some other nation. So for our example, we'll look at Mexico. You do a different one in the homework. So we see Mexico's down here with 1.6 trillion, and the U.S. is over here with 14.6. So we want to know how many times this little pink bar can fit in the U.S.'s orange bar. So if we were to stack them up on top of themselves, how many times would we need to draw Mexico's bar? So what we're doing is we're taking the U.S. GDP of 4.6 trillion and we're dividing it into a bunch of Mexicos and seeing how many different Mexicos can fit in it. So that would be 14.6 divided by 1.96, which comes to 9.125, or about 9 times. So if we were to put Mexico's bar in the United States, we could stack up 9 of those, and there'd be a little bit left of the orange at the top, but it's about 9 of them. Alright, moving on to the next question on that page. It asks you, using this other graph of the world view on page 32, what is the percent of America's GDP per capita available to the average citizen of some other country? We're going to talk about India in this example. You have several countries that you'll work through this with. So we see the average person in India has about $3,560. All of these have been converted to dollars, which is good, so we can compare them. And then the United States has around $47,020 per person. Okay. So we want to know, relative to the United States, what fraction India has. So that means we're going to divide. And we divide by putting India on top and America on the bottom. So when we divide those two numbers, we get 0.0757. But again, it wants to know the percent, so we move our decimal 2 places, and we get that the average Indian or citizen of India has 7.5% of the GDP as the United States. And again, that is per capita GDP, so it's kind of like a measure of income. Okay. So you just do that for all of them, putting whatever country you're comparing to America in the numerator, and then dividing by the American GDP of 47,000. Okay. Right. So the next question that requires a calculation states that if there were 100 million workers producing America's GDP in 2010, how much output did the average worker produce? Again, the number of workers is different in your question. but for this one we're saying suppose there's 100 million workers. So it wants me to go back up to the picture here and figure out how much GDP there was. So there's a total of $14.6 trillion. Okay. So we want to take that 14.6 trillion and divide it up among 100 million workers. Okay. So this one is almost an exercise in decimals. So I want to make this into trillion. Okay, so this is my hundreds, my thousands, my millions, my billions, and then 14 trillion. So that is correct. And we want to divide that by 100 million. Let's get that in the right place. Okay. This one's a little easier to write out. So we're dividing those two. And that'll give us our answer. Oops. Okay. So this set of 3 zeros cancels, and that set, and then 2 more. So I am left with the 14,600, and then 1 more O. So we go back and replace our commas, and we find that this means that the average U.S. worker produces about $146,000 per year of product. Now this is not the same as GDP per capita because we're only counting workers and not all people. Additionally, this 100 million was made up for the purpose of this example, so it would not be remotely close. The answer you may get may be a little closer to the actual GDP per capita in the other graph. Okay. So then the next question wants you to determine how much more income per year we would have to produce in order to provide some amount of money to the severely poor population. So I still have 2.7 billion here because that's the actual amount. And in this example, we wanted to provide them with $5 of output per day more. So we want to be able to give them $5 more than we currently do. How much more are we going to have to make as a country in order for there to be more for them without giving things up ourselves? So to figure this out, we need to find out how much this $5 per day comes to per year for everyone. So we've got $5 per day, and we want to give them that amount for 365 days in our year, and we want to give that to the 2.7 billion people in that category. So we're going to multiply 5 times 365 times 2.7, and we're going to leave the billion alone because the example I have it written in Canvas where I just want you to put in the number with billion as a blank. So it looks something like this, and you just need to fill in what number goes there. So I'm going to leave the billion alone. I don't have to worry with the decimals here. So 5 times 365 times 2.7 comes to 4,927.5 billion. So really that is about 4.9 trillion, but again we're leaving it in billion just to make things easier. And our last question moves to chapter 3. Okay, I have a very similar table but with different numbers here, and we're estimating the supply and demand for some Marvel Studios movies. So to determine the market demand and supply, you need to add up for each price the amount each person would be willing to make. So Tom is willing to make 7 at $30. George is, or buy, excuse me, this is buy.